A bar magnet of magnetic moment 6 joules per torque is aligned at 60 degree with a uniform external magnetic field of 0.44 torque. Now calculate case B, the torque on the magnet in the final orientation in case 2. Here the case 2 is nothing but opposite to the magnetic field. Opposite to the magnetic field means here the theta is equal to 180 degree. Theta is equal to 180 degree. Then we need to find the torque. Torque is equal to magnetic moment, that is M, into magnetic field B sine theta. B sine theta, where theta is equal to 180 degree. If you are going to substitute the values, M value is equal to 6 and B value is equal to 0.44 and sine theta, sine of 180 degrees. Sine of 180 degree is equal to 0, then the whole value will become 0. Torque is equal to 0 here. A bar magnet of magnetic moment 6 joules per torque is aligned at 60 degree with a uniform external magnetic field of 0.44 torque. Calculate the work done in turning the magnet to align its magnetic momentum normal to the magnetic field and opposite to the magnetic field. And the second one is the torque of the magnet in the final orientation in case 2. Case 2 means opposite to the magnetic field we need to find. Okay. We need to find first here the work done. That is work done is equal to magnetic moment. We can write that one in terms of M, and the external magnetic field that we can write in terms of B with respect to aligned angle, that is initial angle, and the respected given term, that is normal to the magnetic field, that is cos theta 1 minus cos theta 2. Okay, where theta 1 is the 60 degree and theta 2, the condition is given, that is normal to the magnetic, that is 90 degree. If we substitute the values, that is theta 1 is equal to 60 degree and theta 2 is equal to 90 degree. Substitute the values, then work done is equal to M into B cos 60 degree minus cos 90 degree. M into B for cos 60 is equal to 1 by 2, cos 90 is equal to 0. Then this becomes 1 by 2 M into B, where M value is given, that is equal to 6, and B value is given, that is equal to 0.44. Now, 3 times 6, 3 times of 0.44 is equal to 1.32 joules. This is the first condition, that is normal to the magnetic field. And the second condition is opposite to the magnetic field. Opposite to the magnetic field means here the theta 2 will becomes 180 degree. Then substitute the values, we get the answer same. That is W work done is equal to, directly substitute the values, M into B, M is equal to 6 and B is equal to 0.44 and cos 60 degree minus cos 180 degree. Cos 180 degree. Then 6 into 0.44 0.44 into 1 by 2 minus of cos 180 is equal to minus 1. Then this becomes 6 into 0.44 times of 1 by 2 plus 1. 1 by 2 plus 1, which is nothing but 3 by 2. That is 6 into 0.44 times of 3 by 2. 3 by 2. Then again here 3 times. If I'm going to get cancelled this one, if I'm going to get cancelled these terms, that is 3 times, then 3 times 9. 9 times of 0.44, which is equal to 3.96 joules.